Hi everyone. This one's a really nice one. There's different versions of this, so it might not be exactly the same, but they should all be kind of similar level of difficulty. So these are linear in your trig function. There's no cosine squared or sine squared or anything like that. In fact, here the cosine only appears one time and has no powers or anything else weird. So you're just going to want to start by isolating the trig function. So I'm going to say 2 cosine x minus 1 equals 0. I can add 1 to both sides, which will leave me with 2 cosine x equals 1. I can divide both sides by 2, which leaves me with cosine x equals 1/2. And whatever version of this you might have, you should get a special value. So for cosine equals 1/2, cosine represents x values on the unit circle. So I'm saying my x value is equal to 1/2, which puts me a little closer to the y-axis in quadrant 1 and in quadrant 4. Those are at your pi over 3, and then the bottom one you can either call negative pi over 3 or 5 pi over 3. Either way is fine. I like that plus or minus notation, so I like to do positive and negative pi over 3. So whatever your special value is, if it's sine, remember you're talking about y's. If it's cosine, you're talking about x's. Find those two locations, and then once you've got them, you just need to tack your period on. So I can actually write mine as a single statement using the plus or minus. If you've got a sign, that's not going to work. You're going to write them out as two separate statements, or you could even do it here. The first one could be positive pi over 3, and then the second one could be x equals negative pi over 3, and then both just get a 2 pi k on the end. And you always want to specify that k is in the integer, but I think that was done for you in this one. So that's what we're looking at.